All right, we've talked about area of a circle and circumference of a circle, but now we're going to talk about sector area and arc length, which we can see are just portions of that. But first, let's look at these first two circles. How do you find the area of the shaded region? That's the sector in each circle. The first one, well, obviously the shaded part is half of the circle. So we would find the area of the circle, which is pi r, which is 12 divided by 2, because that's the diameter, 6 squared, or 36 pi, and then 1/2 of 36 pi gives us 18 pi centimeters squared, or as a decimal, at 56.55 centimeters squared. We'll literally just cut it in half because it's half our circle. Now looking at the second one, we can do something very similar. So either way, we need to find the area of the circle first. So it's pi r squared, so it's 25 pi inches squared, all that. I don't want to worry about units yet. Now, how much of the circle is shaded in? Well, if you made that thing 3 more times, it would make up the whole circle. So it is 1/4 of the total area that we got of the circle. So the exact answer is 6.25 pi inches squared. The decimal answer is about 19.63 inches squared. So these are kind of intuitive when you think about it. It's nothing different than really what we've done before. So now what about a sector like this? 64 degrees, we got our radius. Well, we don't know how much of a circle 64 degrees is. So, well, we knew that in number 1, or the first one, it was half. Because what is the measure of this angle? Well, that's 180 degrees. We had the measure of this angle in the second one, that's 90 degrees. So we really put 90 over 360, which is the 1/4, and we did 180 over 360 equals that 1/2. So that's how we got those. So we can do the same thing. It won't look as nice. Oops. 64 degrees out of the whole circle, which is 360 degrees. To the area of the sector over the area of the circle, which of course is pi r squared. And of course we know r is 3, so we can write that. Then we can cross multiply from there. When we do that, we get 576 pi equals 360 times x, or the area of the sector. We divide by 360. And we get approximately 5.03 inches squared. So we don't even know exactly what proportion of the circle 64 is, but you can see it's about 1/6. And 1/6 of the area apparently is 5.03 inches squared. So area of a sector with central angle theta. There's 2 ways we can write this formula. One as a proportion. Theta over 360 equals the area of the sector over the area of the circle, so pi r squared. Or basically the same thing, but it would be theta over 360 times pi r squared equals the area of the sector. Really is the same thing. The second one might be a little bit shorter, just if we're going step by step. but they're still all the same thing. So now we got two more here. So number one, we got a 165-degree angle here. We got a radius of 3. Find the area of each sector rounded to the nearest hundredth. So we want decimals this time, and we want 2 places after the decimal. So again, we just do 165 over 360. And we can either multiply it by the circle area or write the proportion for it. Area of sector, we don't know. And it's pi r squared. When we cross multiply and we divide by 360, overall we have 12.96 units squared. I want us to get in the habit of using squared on our units, even though we don't have a unit in that problem. Now number 2, we'll do the other way, even though it's the same thing. Find the area of the shaded, or of each sector. So now, we don't want the 130. We want the rest of the circle, because that's the shaded part. So 360, minus 230, 130. If my pen will work. And that'll give us 230. That's what this angle is, 230 degrees. It's over a straight line, because it's over half of a circle. So it's 230 over 360, then just times pi times the radius squared. We just throw that all in our calculator. We get 200.71 units squared. Not difficult calculations. We will even give you these formulas on the test. You don't have to memorize them. Not that you couldn't, but we don't need to. So what is a sector? We've talked about the area of a sector, and we haven't talked about what it is. Is a portion of the circle's area defined by a central angle. It's a piece of pie. Or a piece of pizza. It's like that triangle with the circular edge. An arc is a portion of the circle's circumference, also defined by the central angle. So sector area, we were talking about a certain portion of the circle's area. Well, with arc, or arc length, we're going to find a portion of the circle's circumference, because we'll be finding the distance around. So, the length of an arc with central angle theta, we can write it 2 ways again. Theta over 360, hopefully that's looking familiar, equals arc length over our circumference formula, 2 pi r instead of pi r squared. Other than that, it's the same. Or, just like the other one, we could do theta over 360 times our circumference, and that'll give us the arc length. Either one is equally successful. Do whichever one makes more sense to you. So let's find the length of arc LM. So that's this red part here, or the green that I squiggled on there. That's the distance that we want to find. So that is just 64 out of 360 of that whole circle, just like it was with the area. We don't know the arc length. And instead of a portion of the area, we're doing a portion of the circumference. So that is 2 times pi times 3. So we cross multiply, we divide by 360, and x turns out to be approximately 3.35 inches. And it's not squared because circumference is linear. It's just a distance around. It's not two-dimensional. So that's it. Let's try a few more. Then we'll throw some curveballs at you. So find the length of the indicated arc, rounded to the nearest hundredth. So number 3. Well, we got our angle, 138, because we want arc ABC. So that is the minor arc, and we have 138 out of 360 times the circumference 2 pi r. We don't have r. I don't know why, but we'll just pretend it's 6. Again, just multiply all that up. We get approximately 14.45 inches, or not inches, sorry, units. There's no units there, but I still want us to get in the hang of that, doing that. Now, looking at number 4, same thing. We'll do the proportion way of looking at the formula. So it's 44 out of 360 equals the arc length, or x, over the circumference, so 2 pi r. So we cross multiply, we divide by 360, and we get approximately 27.58 units. So very similar to what we were doing before. Okay, now these problems kind of flip it around a little bit. We're going to be going backwards. So the length of the measure of the minor arc AB is given. So we have the arc length. We need to find the measure of the angle AQB to the nearest hundredth. So we can set up the same equations we've been doing. I think it's easier to look at the proportion, although not impossible to look the other way. So equals our arc length, which is 8.73, over our circumference, which is 2 pi, times the radius, so 10. We cross multiply. This time we're going to end up dividing by 2 pi, or 20 pi, the 2 pi times the 10. So when we cross multiply, all said and done, and we put it as a decimal, theta is approximately 50.02 degrees. Again, I think it's easier to use the proportion, but you don't have to. Now again, if we didn't here, this is what it would look like. So 40 over 360 equals, the area of the minor sector. So we're talking about area now, not arc length. So that would be our area of a sector, which in this case is actually 35 inches squared, over the area of the circle. We don't know the radius, so that's pi r squared. So we can cross multiply, and again, it's much easier this way if we'll talk about the other way in a second. So when we cross multiply, we get 40 pi r squared equals 12,600. We're going to divide by the 40 pi because we want to get r squared by itself. So r squared is approximately, not there yet, 100.27. That's the radius squared. We want the radius, so square root of both, and r is approximately 10.01. So pretty close to an integer, just like theta in the last problem, but it's not, and you can't round more than you're supposed to. All right, so number 6, let's do this using the other way of writing the formula. So the length of measure minor arc CD is given. Find the circumference and area of circle Q to the nearest hundredth. So it's theta over 360 times, we're doing minor arc, so we're talking about the circumference, so 2 pi r. Now we don't know the radius, but we know the arc length is 7.5. So this is kind of nasty. I think it'd be much better to do the proportions. If we weren't, well, we could divide by 2 pi r on both sides. So on the left, they cancel out. We got 76 over 360 equals, see, 2 pi r times 7.5 is 15. Wait a tick. No, we want to divide that. And what do you know? Whoops, that's 7.5. So either way, we're end up at the proportion. So let's just keep it this way. So we cross multiply. We got 152 pi r equals 360 times 7.5 is 2700. And now we'll divide by 152 pi. And because we're dividing by pi, we know that we're going to get a decimal answer. Make sure you put parentheses around the 152 pi because we want to divide by both of those things. When all is said and done, our radius turns out to be 5.65. But that's not what the question asked. The question asked for the circumference and the area of our circle. So of course we got to bust out those formulas. 2 pi r squared. So with our radius being 5.65, we just plug that in to both formulas. And when we just multiply it all out, our circumference is approximately 35.50, and our area is approximately 100.29 units squared, and we got units on the circumference. I think we forgot those. Well, we just forgot that on number 7 there when we were finding the radius. All right, one last question, then we'll call it a day. The area of a major sector is, so we want to use our area of a sector formula. So it's theta, which we don't know. Theta is going to be this angle. So it's theta over 360 equals the area of the sector, which we know this time is 415.63 feet squared. But we don't know the area of the circle because, oh no, yes we do. It's pi r squared. So very similar setup to what we've been doing. We're just trying to solve for the angle this time. When we cross multiply and divide by 14 squared pi, theta turns out to be approximately 243 degrees. And that is, well, actually what we found there wasn't theta that we wanted. It is, actually, get out of here. What we found was the other side. And we can tell because the angle's over 180 degrees. It's more than half a circle. So when theta is 243 degrees, it's not really theta, we'll call that x. That's how we got our angle form. Then from there, we want theta, which is 360 minus what we just found. So 360 minus 243, so approximately 117 degrees. And that's the measure of angle FDE. the theta that's actually marked on our diagram. And then the length of the minor arc. Well, we know the angle this time. It's always at a 360. Arc length is what goes here, which we don't know. And the circumference is pi, or 2 pi r, and r is 14. So when we multiply and divide by 360, we get that the measure of arc FE, or our arc length, is approximately 28.59 feet. And it's not squared because it's not area. It's just linear units. And that's how you do what we're talking about.